The thought of 3D scanning can conjure images of expensive equipment, lasers, and even robot arms, feeling like some sort of out-of-reach luxury to those just wanting to experiment without expert knowledge or a budget. For many that feel like that, photogrammetry may be the solution you're looking for, allowing you to capture detailed 3D scans of anything you want, needing nothing in the field with you other than a camera. Today I'm going to be going through what photogrammetry is, how it works, and how suitable it is for use with 3D printing, so let's take a look. In short, photogrammetry is a way of 3D scanning an object in the real world with the goal of creating a digital 3D model simply by taking photos of the object from a wide variety of angles and then running those photos through some software. It's been suggested that the root of photogrammetry dates back to Leonardo da Vinci's work on perspective in the 1400s. The term photogrammetry was later coined by an architect in 1867, but the method he was referring to has been attributed to an engineer who in the 1850s was developing techniques for surveying buildings and landscapes using photography. Using two photographs taken from different positions and analysing the parallels, he was then able to determine the spatial positioning of the building. Today, photogrammetry is used professionally around the world for a huge list of applications. It's used for architecture, forensics, 3D modelling, cartography, medical imaging, film and TV, archaeology, and so much more. Effectively, all you need to do is take photos of your object that you want to scan from multiple different angles, ensuring that every spot of every surface of that object is visible from a variety of different perspectives. Then take those photos and run them through some photogrammetry software. Unlike other 3D scanners, which rely on special sensors to determine distance and shape, photogrammetry uses this software to simply compare the colour information of standard photos. As the software establishes key points in different photos that match, it can then determine how the photos need to be folded so that all the points fit together in 3D space. It's due to it being entirely reliant on colour information from photos that unique and visible texture or pattern on the object, as well as consistent lighting, is extra important in photogrammetry. So in other words, the super smart software used in modern photogrammetry is effectively following the same process that was being done entirely manually back in the 1800s, albeit with a lot more detail. Using the details that it can see in the image, as well as the image metadata which lists the camera, lens and settings used, it will also determine the relative position of the camera for each of the images. Understanding where the camera was when each of these pictures was taken will give it a better understanding of the shape of the object that they're all looking at. If the photos were taken on a device with GPS, and that information was also saved to the photo's metadata, that can also be used for helping position the cameras, potentially allowing for a higher level of accuracy, especially with larger scans, and much faster processing. It's important that each photo you take has a good overlap with its neighbouring images. This is because there needs to be enough uniquely identifiable points which you can see from multiple images. The object you're scanning should cover at least 60% of the frame, and ideally they should overlap by around 70%, so you should only make fairly small movements between each photo. When capturing images for photogrammetry, the standard plan is to take photos at 10-degree intervals in a loop around the object, with the camera always facing in towards the middle. Then repeat that loop at least 2 more times, one higher and one lower, separated by 30 degrees from the initial loop. Then take 2 or more sets of photos, again at 10-degree separation from one another, this time in an arch from one side over the top and down the other, repeated 1 or more times, starting from different sides of your object. Once you've completed all of these shots, taking a step or 2 back and doing 1 more loop from a wider perspective can provide a good reference for camera positioning in the software, though this isn't essential. Take your time when you're taking these photos. If you're moving too quickly, you're going to introduce motion blur to the photos, and that's not going to do the scan any good. But before you start taking them, you want to make sure that the conditions you're shooting in are optimal, and this mainly comes down to lighting. Basically, you want to make sure that the object that you are scanning is softly and evenly lit from every direction that the camera will be facing. You could do this by placing light panels all around it, ensuring that nothing is in contrasted shadow but equally not too bright that would result in overexposure. Or if you're scanning a smaller item, i.e. not a building, you could use a ring flash fitted to your camera, which will ensure that the object is evenly lit from the direction of the lens wherever you move the camera. Equally as important are your camera's settings. It's all fairly straightforward, but it's worth mentioning. Firstly, you want to use the highest resolution camera and settings you can. The higher the resolution, the more details the image will capture and the more accurate your scan will be. Also, if you've got the option, shooting in RAW will give you a bigger dynamic range, capturing more details in the highlights and shadows. Focus and aperture are key factors here. Obviously, you want your object that you're scanning to be in focus, but you want as much of it to be in focus as possible. Using a fine depth of field, even if it only blurs the background, will affect how well the software can position the cameras. To get around this, you'll want to use a narrow aperture to increase the depth of field, the depth of the area that's in focus. The issue here is the smaller the aperture, the less light is let in and the darker the image. So it becomes a bit of a balancing act between aperture, shutter speed and ISO, where you're looking for the deepest depth of field without the image getting blurry from long exposure or too noisy from a high ISO, and ensuring that it's also not too dark. I'll be going more into the best ways of finding the right settings for this in my tutorials which I'll be producing after this series is over. As we'll see in a bit, you can often get away with just using your camera in auto, but you'll still want to ensure that your image is evenly exposed and in focus before taking each shot. So what do you need to do photogrammetry? I bet you need some big fancy camera and some super expensive premium software. Well, actually, no. Unlike other forms of 3D scanning which can require dedicated hardware with you while scanning, photogrammetry is far more accessible. The first thing you do need is a camera, and whilst you may get more control over the settings and image with something like a high-resolution DSLR, you can use pretty much anything with a camera, whether that be a dedicated camera or just the camera on your phone. You'll also need software to process the images, and there's a couple of ways you can go with this. There are some mobile apps available, so you could just take the photos on your phone and then just upload them directly for processing server-side. For the most part, these mobile apps tend to either produce models of limited detail, or you need to pay for the server-side processing. Either way, doing the whole thing on your phone can limit the control you have over the results. The other option is to do the processing on your computer. There's a wide range of software available, and if you want to produce high-quality photogrammetry scans without paying for server-side processing, this is the way to do it. This is what we'll be doing in today's video, but we'll be looking more into the mobile side of things in next week's episode, when I'll be exploring the various mobile and web apps available for 3D scanning. Whilst there is expensive premium photogrammetry software, which does have its own merit, there is also a wide range of completely free and professional grade photogrammetry software available. A popular one is Meshroom by Alice Vision. This is completely free and a fully featured piece of photogrammetry processing software. It's worth noting though that this does require CUDA for anything beyond draft meshing, so you'll need an NVIDIA GPU and CUDA installed for creating high quality scans with Meshroom. Another option is Zephyr by 3D Flow. Whilst there are premium versions of Zephyr available at anything from 200 to 4,200 euros plus VAT, they also have a completely free version available for personal use. The main restriction for this free version is that you're limited to using a maximum of 50 photos per scan. That should be about enough for a small, simple object, but for medium or larger scans, they can involve several hundred or even thousands of photos. Then there is Reality Capture by Epic Games. For those not familiar, Epic Games developed and run Unreal Engine, the platform that a huge portion of both AAA and indie video games are built on, and which is also used for CGI and LED volume control in TV and film, with popular titles such as Matrix Resurrections and The Mandalorian. All three of these options I mentioned are only available on Windows, with the exception of Meshroom, which is also available on Linux. This seems to be a bit of a trend with photogrammetry software, where a lot of it is not compatible with macOS. Metashape by Agisoft, however, is a popular option that's available on Windows, Linux and Mac. Unfortunately though, unlike the other three, Metashape isn't free. Whilst there is a perpetual demo mode, for full access there is only a 30-day free trial, and after that you'll need to buy a license. The good news is, if you did decide you wanted a license, Agisoft haven't yet succumbed to the financial allure of the subscription-based model, so you can acquire a license with a simple one-off fee. Of the options I've listed here, I tend to find that Meshroom outputs the absolute highest quality, or at least the highest quality relative to the minimal effort on your part. but it can also take significantly longer to process than some of the other options, and it's not so well set up for cleanup and post-processing. Today, in this video, I'll be running my photogrammetry scans through reality capture. As well as a camera and the software, you'll of course need a computer to run the software on. Now, technically, you could run the software on pretty much any computer, but photogrammetry processing is a very power-intensive task, and even when using a more capable computer, it can take several hours to process a scan, and even longer if it's particularly detailed. So whilst you don't have to have a super powerful computer, the better your CPU and GPU and the more RAM you have, the faster the processing will be and the bigger and more detailed these scans you can produce. That's everything you need that's absolutely essential for photogrammetry, but there are some other items that you may find useful. Some of them you may already be aware of if you're actively into photography. As I mentioned earlier, the purpose of this video isn't to be a deep dive tutorial, but I will be covering many of these additional items in my photogrammetry tutorials that I'll be working on after this series. Whilst I hope you will watch this entire series, make sure you tune into episode 5, where I'll be going more into 3D scanning spray, which can be useful for photogrammetry when scanning transparent or reflective objects. Unlike other forms of 3D scanning, which can intrinsically know the scale of the thing that it's scanning, photogrammetry has no idea how big an object is. If it's important that your 3D scan is dimensionally accurate, placing a ruler or a simple object of known scale into the 3D scanning area can be really useful, because you can then scale up or down the resulting 3D model so that that object is the known size and the rest of your scan is going to scale relatively. With some software, including reality capture, you can create a scale bar and place it in the scanning area. The software recognizes it and understands the size, automatically scaling your entire scan accordingly. As with Unreal Engine itself, to install reality capture, you first need to download and install the Epic Games launcher. While we're here, they also have Reality Scan, a mobile app which leads us nicely into next week's episode, where we'll be looking at mobile and web apps, especially those leveraging the advantages of AI and other machine learning for 3D scanning. But for now, we'll continue installing Epic Games Launcher so we can get reality capture. This is the same software that you'd use for launching a game that you've bought through Epic Games. With it installed, you can then download and install reality capture via that. As I mentioned earlier, for photogrammetry, you want to take photos of your object from every angle from multiple levels. When you're working with smaller objects, it may be tempting to put your camera on a tripod and then put your object on a turntable in front of the camera, rotating the turntable between each photo. This method works great for some types of 3D scanning, but for photogrammetry it's generally not recommended. Photogrammetry uses everything it can see in the photos you take, including anything in the background. It then uses this information to try and figure out the camera positions and therefore the geometry of your object. If you had a static object and you moved the camera around it, then the positions of the background would be relative to the positions of the object, apart from obviously the parallax, but the software understands that, and this information will then only aid the accuracy of the scan. If you use a turntable, on the other hand, anything that it sees in the background will remain static whilst the object is being rotated. This can confuse a lot of photogrammetry software, although it is technically possible. If you really do need to use a turntable, you want to make sure that any background that's visible in the picture is completely blank and void of any recognizable track points. So use something like a plain white evenly lit wall featuring no shadows, and ensure that there's a good amount of space between your object and it. One of the real advantages of photogrammetry is that all you need with you is a camera, meaning that you can capture a 3D scan of pretty much anything, anywhere. These dark and slightly reflective statues are already a challenge for photogrammetry, and the harsh sunlight isn't helping. Outdoor 3D scanning already has to deal with the uncontrollable environment, but today's conditions are particularly tough, throwing half of these statues into strong shade while the other half is flooded with sunlight. I'm hoping that my phone's auto settings that I've opted to use for today's test can handle it, but I'm not holding my breath. We'll have to see what the camera gods have in store for us. Once you've taken all your photos, before you throw them into your photogrammetry software of choice, you'll want to quickly go through them and assess them, deleting any that are blurry or otherwise unusable. Whilst at this point it might be tempting to crop some images, undistort them or run them through an AI upscaler, none of this is recommended for photogrammetry. AI upscalers create new information, and whilst it's an educated guess, it's still a guess. So it's going to create new information which is completely different for every photo, and that will confuse the software. Photogrammetry software uses the information in the image's metadata, so it understands the camera, the lens, and the settings that we used. If you were to crop an image, it's then going to confuse the software further, and it may try and apply unnecessary corrections. Whilst you shouldn't make any structural changes to your photos, you can adjust things like brightness and contrast for better software recognition. Editing your photos in Photoshop or Lightroom can ensure better exposure and consistency across the images. Lightroom is especially efficient for editing large batches of photos, saving you time and ensuring a cohesive look. The exact steps to follow when processing images for photogrammetry vary depending on the software you're using, but most of them follow a fairly similar path. Import all of your images and get them aligned. The software may flag that some of the images have been omitted and it can't find enough comparison points in it, but as long as this is kept to a minimum, that should be fine. This alignment might take a while and will depend on the complexity of the scan and the power of the computer, but can take anything from a few minutes to several hours, even with a powerful computer. Next, you want to create a 3D mesh. Some software, like Reality Capture, will allow you to create a draft mesh first, which is much quicker, and with that you can then select and delete any areas that you don't want, for example the background and other objects that you didn't want to include. If you created a draft mesh, you can then create a higher quality mesh, and this will be much quicker now you've deleted all of the areas you don't need. Then you can run modifications like simplifying it to remove complex detail that just won't be visible in your specific use case, making the model much quicker and easier to use on your computer. Some software like Reality Capture also has nice features like smoothing and model cleaning that'll try to remove any defects from the model and smooth out any bumps and errors. You'll notice that this side of the statue is far less detailed and features more errors than the other. This is the side that was in shade and so is much darker in photos due to the hard sunlight. This highlights the advantage of outdoor photography on overcast days, as opposed to sunny days like when I did this. More even lighting across the model means better results. If shooting in bright sun is unavoidable, try to use a camera with wide dynamic range to capture details in both light and shadow. Reality Capture also offers features like close holes to patch up any gaps in the scan. Sometimes you might need to use another program like Mesh Mixer to convert the model into a solid object, depending on the photogrammetry software that you used and the complexity of the scan. The side of this Cary Grant statue that was facing the sun has come out fairly well, and doesn't seem to have been too badly affected by the reflectiveness of the surface. The side in shadow, though, lacks a lot of detail and seems reminiscent of the popular low-poly 3D prints that you can download. Let's see how this comes out as a print. Whilst the shaded side definitely has less details and isn't quite as clean as the other side, I'm actually quite impressed. You can see the folds in the sculpted material of his coat, the details in his face, and even just about make out the buttons on his shirt. I actually think it's quite amazing that this 3D scan was produced just using a mobile phone, and in pretty much the worst possible lighting conditions. It didn't take long to capture the images for this scan, so whilst I was there I also scanned a couple of others, and I processed and printed them to see how they came out. With the Thomas Chesterton statue, it seems I focused a bit too much on the statue itself, and forgot that I'd also be printing part of the bench, so all the details in the bench are just what the software picked up from the background. I actually feel that the rhinoceros beetle came out surprisingly well. Certainly still not perfect, but it will have been helped by the fact that it was sitting in the shade, so it had for the most part slightly more even lighting. I think it's brilliant I was able to capture these 3D models just using my mobile phone, but whilst in many use cases these would be more than good enough, I understand that they're definitely not perfect. But this also isn't a great representation of what photogrammetry can do. For this test, I was purposely using just my mobile phone in auto and shooting in terrible lighting conditions. Shooting the same subject on an overcast day with a DSLR with manual settings would definitely produce a much better quality model, and even just using a mobile phone, taking more time and covering the scan with more photos would definitely help. So we've experimented with some smaller objects here, and for the record, photogrammetry can definitely deal with significantly smaller items than that. But where it really shines is capturing vast spaces, whether it be giant statues, topography, or buildings. For example, several years ago, I spent 4 months filming an Egyptology series following various archaeology projects around Egypt. A lot of them employed photogrammetry as a way to be able to quickly and cheaply produce detailed and colour-accurate 3D models of entire temples or tombs, needing nothing on site but a camera. But whilst you can do this all with a camera phone or DSLR, there is another way of capturing images for photogrammetry which makes scanning particularly large things like buildings or landscapes far easier. As I said before, you can do photogrammetry with pretty much any camera, and that includes a camera on a drone. Drones are a great way of being able to easily 3D scan a large object such as an entire building. You can do that using special software where you can just draw an area on a map and it will automatically fly the drone across that area, taking all the photos you need for your 3D model. Alternatively, you can do it manually, and this is the same process as doing photogrammetry with an SLR or your mobile phone. You just need to make sure that you've taken enough photos of your object from every angle at a few different heights. So we're going to do that here, we're going to do this manually. Let's see how this comes out. Whether using a handheld camera or a drone, capturing photos from every angle is the key to photogrammetry. With a drone, you can either circle around the building at different heights, snapping photos every 10 degrees, or you could ascend vertically, taking photos at regular intervals, and then rotate and repeat. Alright, well, let's see how that scan comes out. I just wanted to quickly mention that if you hit the join button below my video, you can become a channel member, a 3D revolutionary. Not only would you be supporting me making more videos in the future, you'd also bag yourself members' benefits, including early access to my videos, exclusive access to the 3D Rev Discord community, and a members discount at 3drevolutionstore.com, where you'd find 3D printing and maker-themed clothing and accessories, including that rather fetching 3D Rev cap I was just using to keep the harsh sun out of my eyes. Right, let's see how that scan came out. As I mentioned out there, there is special software you can get which will control your drone and automatically take all the photos you need for a scan. One of the more popular options for this is Pix4D. Whilst it is a paid platform, it does have a free trial, but unfortunately my better quality drones aren't currently compatible, which is one reason why I opted to do this manually. However, whilst my Mavic 3 Pro Cine isn't compatible, the non-Cine version, the Mavic 3 and Mavic 3 Pro, is, along with a huge range of other drones with high quality cameras. As these photos were taken on a drone, the GPS and compass information is saved to the metadata, which is then used for quicker and more accurate positioning of the cameras in the software. Not only was the lighting harsh that day, as with the statues, but it was also quite windy. Whilst the drone handled the wind fine and short exposures prevented any motion blur in the photos, the wind can still cause an issue with photogrammetry. Wind can be particularly problematic, as not only does it mean that objects like branches and leaves of trees can be in completely different positions or even shapes between photos, but if you're shooting in harsh lighting, the shadows from those objects are also going to be in different positions and shapes on your object and the surrounding area, and again that will differ between each photo. To try to get around the issue of the tree blocking the view of the house from certain angles, after the flight was complete I then took additional images handheld from under the tree, but that still didn't completely help with the moving shadows and contrast. Due to being both transparent and reflective, windows are common issues when scanning buildings, so the best thing to do with these is just to delete them and then add a flat surface to the model digitally. The harsh sunlight and sloping terrain made capturing the back of the building difficult. The deep shadows and limited drone access prevented me from getting an ideal amount of images here. I did adjust the contrast and brightness of the images though, so I managed to recover some of the detail from the dark. Much like the tree, the plants that were growing directly in front of the house were also moving in the wind, and was something that I couldn't do anything about on the day, so they all just need deleting manually from the model and it will need cleaning up. This will definitely need some extensive cleanup to make it suitable for 3D printing, due to the issues caused by the plants and trees moving in the wind, the shadows that they cast, and the harsh lighting. It may even be best to just rescan it on an overcast, less windy day, so I'm not sure if I'll be printing this one. Either way, you can clearly see the level of detail that you're able to achieve with this method, being able to see the shape and structure of each individual brick and roof tile with surprising precision. Even stripping away the colour information, you can see that the detail is there built into the 3D mesh itself. So there are some real positives here. At its core, photogrammetry has a very low entry requirement, a camera, making 3D scanning accessible to almost anyone. As a result of its basic entry requirements, it's one of, if not the cheapest ways to get into 3D scanning. Photogrammetry's versatility is a huge advantage. Whilst some 3D scanners are limited to only being able to scan quite small things, and others are limited to only large things, photogrammetry can be used to scan anything from the size of a tennis ball to an entire city. That, plus its excellent colour mapping abilities, makes it a frequent favourite both for hobbyists and also industry professionals in a range of sectors. If you're looking at starting out in 3D scanning and you're not aiming for perfection, it's fairly easy to pick up photogrammetry. But be prepared to spend some time learning how you can clean up and fix your models before you can print them. Whilst versatile, capable and accessible, photogrammetry is definitely not without its challenges. Complex and large models demand experience and powerful hardware, and there's definitely a big learning curve when it comes to post-production and learning to repair your scans. Being a purely visual technique, photogrammetry struggles capturing details in black and transparent objects even more than other forms of 3D scanning. They blend into the background or let light pass right through them, making it hard for the software to accurately reconstruct their shape. Keep in mind, your results may vary. Photogrammetry has the potential to produce much better results than we've seen here, but it also has its limitations. In this series, we're exploring the suitability of various forms of 3D scanning for beginners that would like to 3D print their scans. Remember, the more you practice and learn, the better your results are likely going to be. And to help you along the way, I am going to be producing a range of tutorials which I'll be making after this series is over. I love photogrammetry, and even if you primarily use another form of 3D scanning, it's a great skill and tool to have in your arsenal. If for no other reason, then it means you always have a 3D scanner in your pocket. Well everyone, I hope you found this video interesting, and if you did, please do hit that like button and subscribe so you don't miss the rest of this series and my future videos and tutorials. Just as a reminder, you can hit the join button below any of my videos to become a channel member and get yourself a load of goodies. I hope you'll be back for next week's episode where we'll be exploring mobile and web apps available for 3D scanning. But for now, and as always, thanks very much everyone, and until next time, happy printing. If you've just discovered this mini-series, why not check out last week's episode where I used an Xbox Kinect as a 3D scanner. If I've already published next week's episode by the time you watch this, I'll pop a link to that here, but until then that will link to the series intro where I covered a brief history of 3D scanning. Thanks very much everyone, and until next time, happy printing.